Water is all around us. In fact, almost 70% of the Earth is covered with it. It's essential to everything we do. But because it's a universal solvent, minerals and other substances can dissolve in water and contribute to scale buildup and corrosion in boilers, cooling systems, and other equipment. Water systems that aren't properly maintained can also provide a breeding ground for microorganisms that can be a health hazard. Water treatment additives help us to manage these problems, but some additives can be potentially harmful, so we need to learn everything we can about them and what we need to do to handle them safely. This program will focus on how to identify potentially hazardous water treatment products, use safe work practices to avoid overexposure to these products, recognize signs of overexposure, deal with spills and cleanup procedures, treat exposure using common first aid techniques. There are many types of potentially hazardous chemicals: flammables, corrosives, irritants, sensitizers, toxins, even oxidizers, which can make other chemicals more hazardous. Each chemical has its own set of hazards, required safety precautions, and recommended emergency procedures. Flammables and combustibles are a common group of hazardous chemicals. The key to telling whether a chemical is flammable versus combustible is its flash point. This is the temperature at which the chemical releases vapors that can ignite and burn. Liquids that have a flash point of less than 100 degrees Fahrenheit are considered flammable. Undiluted cyclohexylamine, for example, has a flash point of 83 degrees Fahrenheit, which means it's almost always giving off vapors that can burn. But since return line treatments like cyclohexylamine are most commonly supplied at concentrations of 40% or less, their flash points are typically between 100 degrees Fahrenheit and 200 degrees Fahrenheit, which makes them combustibles. Combustibles are much easier to control than flammables because they usually have to be heated up before they'll produce burnable vapors. Oxidizers are a unique group of chemicals that can enrich the oxygen content of other substances. This can make normally safe materials flammable and lower the flash point of materials that are already flammable and combustible. Because of this, oxidizers such as bromine release tablets should be separated from other chemicals when they are stored or being used. Corrosives and irritants are another group of chemicals commonly found in many water treatment applications. Corrosives such as sodium hydroxide and other return line treatments can cause serious, even permanent damage to body tissue. They can be particularly hazardous to our eyes, since eyes are very sensitive and can be damaged easily. Most acids and many bases are corrosive. For example, the sulfuric acid that is used in pre-treating cooling tower water is highly corrosive and can be very hazardous to work with. Unlike corrosives, irritants generally only cause minor temporary inflammation or swelling at the point of contact. While some irritants never have corrosive qualities, other times irritants are diluted forms of corrosive substances. Depending on the quantity that you are exposed to, many return line treatments can be highly irritating or even have corrosive effects. Contact sensitizers such as isothiazolin are chemicals that can cause allergic reactions and should be handled with special care. While some may have no immediate health effects, others can also cause severe rashes and other conditions on contact or repeated contact. Unlike other chemicals, toxic substances have the potential to disrupt breathing, coordination, and other bodily functions. Toxic materials that are found in the water treatment industry include substances such as sodium nitrite. Reactive materials such as sulfuric acid are substances that can be hazardous when they come into contact with other chemicals or conditions such as heat, shock, or friction, even contact with air or water. These materials can generate large amounts of heat, splatter, or fumes when they react with other substances such as water, bleach, sodium nitrite, sulfites, and chlorine. So when you are mixing concentrated chemicals with water, always add the concentrate to the water. Often the first place you get an indication that a chemical may be hazardous is from its container label. The material's label will provide its name and potential health, fire, and reactivity hazards. It may also list specific precautions to take or situations to avoid when working with the material. Some labels may remind you of what personal protective equipment you need to wear when handling the chemical or refer to the MSDS. All labels do not present information in the same way. Some labels are written, others use shapes, numbers, or letters as warnings. Let's look at the 3 types of labels that are used most often. HMIS, Hazardous Materials Identification System. NFPA, National Fire Protection Association. And DOT, Department of Transportation. HMIS and NFPA labels are used primarily by chemical manufacturers to provide customers with the information about the chemicals they are using. DOT labels are required for all potentially hazardous chemicals that are being transported. Both the HMIS and NFPA labels use a color coding system to identify hazards. Blue for health hazards, red for fire hazards, and yellow for reactivity hazards. They also both have white spaces. The NFPA system uses it for special hazard information. The HMIS puts codes corresponding to PPE recommendations into the space on its labels. Numbers are used within each hazard category to indicate the degree of hazard. 0 equals no known hazard. 1 indicates a slight hazard. 2 signifies that the material can be dangerous. 3 indicates that the material is extremely hazardous. And 4 shows that the material can be exceptionally hazardous, even deadly, under ordinary conditions. Special hazards are often represented by icons. The most common is oxidizers. HMIS labels also show the personal protective equipment that should be worn when handling the substance. In the Department of Transportation labeling system, every hazardous material has been assigned to one of 9 classes. Each class has its own base label. Most chemicals used in water treatment applications fall under the following DOT hazard classes. Class 2, gases. Class 3, flammable liquids. Class 5, oxidizers and organic peroxides. Class 6, poisonous substances. Unlike OSHA, the DOT defines poisonous very broadly and includes toxic and infectious materials. Class 8, corrosives. Class 9, miscellaneous hazardous materials. Any hazardous substance that doesn't clearly fit into one of the other 8 categories. DOT labels also employ a color coding scheme. Red is for flammables and combustibles. Yellow indicates oxidizers. A half-black, half-white diamond identifies corrosives. White signifies toxins, poisons, and infectious substances. There is a new international labeling system that is being adopted in the U.S., which will use elements of several of these labeling systems. The Globally Harmonized System, GHS. This will eventually replace the HMIS and NFPA system for all but in-house labels. Always pay attention to the labels on any containers that you encounter. Read them carefully before you use the materials and make sure you understand their warnings. While labels can warn us that a chemical is potentially hazardous, most times they don't tell us enough about what the hazards involve or how to protect ourselves. We need to have more detailed information to be able to work safely with potentially hazardous chemicals. How should we handle and store them? What personal protective equipment should we use? What should we do in an emergency? The answers to these and other important questions can be found on a Materials MSDS, its Material Safety Data Sheet. Chemical manufacturers and distributors provide an MSDS for each of the products they sell. Your facility should keep copies of MSDSs for all the chemicals that you use on file so that you can refer to them whenever necessary. The Material Safety Data Sheet is the primary source of information about a chemical product, so you should always read a substance's MSDS before you use it. The MSDS lists the names the chemical goes by, the company that manufactures it, and any hazardous ingredients that the chemical contains. The MSDS also describes the types of hazards that the chemical may present, first aid procedures for chemical exposures, and spill cleanup techniques. Material safety data sheets can come in different forms and formats, but they contain the same important information. Let's look at the various sections of a typical MSDS. Many companies have adopted the ANSI MSDS format, which is the one we'll use for our discussion. Section 1 of the MSDS identifies the material, listing the specific product name, generic chemical name, and any common industry names. Section 1 also lists the name, address, and telephone number of the chemical's manufacturer, importer, or distributor. This is provided in case you have questions about the MSDS or the material itself. An emergency telephone number may also be listed for quick access or additional information. Section 2 identifies both the physical and health hazards of the material. Section 3 provides information on the ingredients in the material. OSHA requires that all hazardous components of a chemical product be listed on its MSDS. If someone is injured using the material, Section 4 of the ANSI MSDS outlines the basic first aid measures that an untrained person can use before professional medical assistance is available. Section 5 provides information, precautions, and instructions for fighting fires that involve the material. Section 6 tells you what to do in case of spills, leaks, and other accidental releases of the material. Section 7 covers handling and storage practices that will minimize exposure to the physical and health hazards of the material, as well as preserve its quality. Engineering controls, personal protective equipment, and exposure guidelines are covered in Section 8 of the ANSI MSDS. Section 9 of the MSDS describes the physical and chemical properties of the material. The information in Section 10 on stability and reactivity is also needed to determine how to safely handle, store, transport, and dispose of a chemical safely. This section will indicate whether the material is chemically stable or dangerously unstable under normal conditions. While Sections 7 through 10 provide the information necessary to prevent hazardous situations from occurring, Sections 11 through 16 of the MSDS furnish information that is primarily used by medical, environmental, and hazardous material specialists. This includes toxicological information, ecological information, disposal considerations, the one area you will need to pay attention to, and regulatory requirements. Along with the adoption of GHS labels from the globally harmonized system that we've already discussed, OSHA is also phasing in the use of GHS safety data sheets, SDSs, which will eventually replace MSDSs in the workplace. Fortunately, SDSs are very much like the ANSI version of the MSDSs, with Sections 2 and 3 swapped. As you can see, whether you're working with material safety data sheets or GHS safety data sheets, they contain a lot of important information. They are one of the keys to working with potentially hazardous chemicals safely, so you need to be sure that you know where these data sheets are kept in your workplace. Identifying which of the chemicals that you work with are potentially hazardous and learning what their hazards may be is only half the battle. You need to take the process further and act on what you learn so that you can avoid those hazards. When dealing with water treatment products, it's always important that you stay alert, follow the directions on container labels and MSDSs, and maintain a clean and safe workplace. Often this starts with maximizing the ventilation in your work area so you aren't exposed to harmful fumes or vapors. In many cases, you may also need to wear appropriate personal protective equipment. Most often this means safety glasses or goggles, a face shield, safety shoes, gloves, and perhaps a rubber apron. At times you may also need some type of respiratory protection. Protecting your eyes is particularly important. Many boiler treatments, such as sodium hydroxide, are highly corrosive and can cause significant eye damage, even blindness. In most cases, it's more practical to work to avoid generating dust and fumes than to have to use respiratory protection. However, there may be occasions where you'll need to use a dust mask if you're handling powders, or a chemical filter respirator if the work that you're doing generates hazardous fumes. But don't forget, you shouldn't use a respirator without proper training and a medical evaluation. This is another situation where you need to read the MSDS thoroughly before you work with any chemical. It will tell you exactly what PPE you should use to handle it safely. Even after taking precautions, there are situations where you can be exposed to chemical hazards. So it's important that you know how exposure can occur, what is involved, and how to recognize the signs of exposure. This is so important that OSHA requires it. So before we go any further, there are a few technical terms and phrases you need to understand. The duration of exposure is the length of time you are exposed to a substance. Exposures can be either short-term or long-term, depending on how long the chemical is on your skin or in your system. The results of an exposure can be either acute, immediate, or chronic, occurring over a longer period of time. In most cases, a short-term exposure will cause no long-term health problems. However, short-term exposure to some hazards can cause acute effects such as a rash or burn. On the other hand, it may take long-term exposure to some hazardous chemicals to cause chronic health effects. For example, being exposed to sulfite oxygen scavengers for many years might result in respiratory problems such as asthma. The dose or amount of a substance you're exposed to is also an important factor as far as possible health effects are concerned. The larger the dose, the more serious your reaction may be. Routes of entry are the way that substances can get into the body. They include skin contact, inhalation, and ingestion. Solids, liquids, and gases can all be absorbed through the skin, but liquids pose the biggest threats because they are the most easily absorbed. Inhalation is when you breathe in or inhale a hazardous substance. Dust, mists, fumes, vapors, and gases can all be inhaled. Fumes from oxygen scavengers, particularly when they are concentrated in shipping containers, are especially dangerous. The third route of entry is ingestion, swallowing. This can happen if you eat some food that has been contaminated with a hazardous material, or you accidentally transfer a material to your mouth or face with your hands. So you don't want to store your food or eat around hazardous substances. Now let's talk about the types of substances that we can be exposed to and how they can affect us. As we've seen, corrosives and irritants are a group of chemicals commonly found in many water treatment facilities. Skin contact with corrosive substances can cause redness, swelling, blisters, and even severe burns. Getting corrosives in your eyes can result in permanent eye damage or blindness. Inhaling or breathing in corrosive chemicals can seriously damage the delicate tissues in your nose, mouth, throat, and lungs. Unlike corrosives, irritants generally cause only minor, temporary inflammation or swelling at the point of contact. Since toxic substances have the potential to disrupt breathing, coordination, and other bodily functions, which can also occur due to other medical conditions, it can be hard to determine whether or not someone is suffering from the effects of a toxic chemical. If someone exhibits these types of symptoms, you should call for medical help immediately. When help arrives, be sure to let them know what chemicals the victim has been working with. While we hope they will never occur, a spill of a hazardous chemical could happen at any time. While proper planning and good work practices can eliminate most spills, you should be prepared for an event that could endanger others. If you don't know the right way to deal with a spill, you can endanger the entire facility and put the lives of coworkers and other employees in jeopardy. Remember, people's safety is your primary consideration. You need to make sure that coworkers and others in the area are out of harm's way before taking action to combat the spill. To start, you should be familiar with your company's emergency response plans. These detail how people should report and handle emergencies of any type, including chemical spills. These plans explain the roles of emergency response personnel and the lines of authority to be followed during an incident. It also covers methods of communication, personal protective equipment, evacuation procedures, and decontamination. The first thing to remember with a spill is not to panic. If the spill is of a chemical that you are using, you will know immediately whether it is hazardous or not, since you've already looked at the product label and made sure you are familiar with the information on the product's MSDS. If you encounter a spill around your worksite, you need to determine if the chemical is, in fact, hazardous. The best way to do that is to look at the container label. But remember, you must protect yourself from any spillage. The functions that you perform during a spill depend on what the emergency plan dictates, as well as what type of training you've had yourself. Remember, in the event of a leak or spill, you must act quickly. The first concern is people's health and safety. Tend to injuries immediately, evacuate the area if necessary, and notify the appropriate personnel. Should your spill exceed the size or be a different type than designated in your emergency plan, notify your supervisor or safety manager so they can get outside assistance. If you're going to be involved in cleaning up a hazardous spill yourself, make sure to use the proper PPE and cleanup equipment. Check the chemical's MSDS. First, you must work to contain the spill and minimize contamination. Create a barrier around the spill with an absorbent material. If there is a spill cleanup kit available, use it. In most cases, the spill will need to be absorbed with a neutral material, but spills of some substances require special procedures. For example, non-sparking tools should be used for cleaning up a flammable substance. And it's important to remember that you can't just throw hazardous material into the trash. Many chemicals are classified as regulated waste and must be removed by licensed disposal companies. Check with your supervisor or facility safety manager. If you or a coworker is exposed to a hazardous chemical, you need to act quickly to minimize the damage that it can cause. To be able to do that, you need to have already read the First Aid Measures section of the MSDSs for the chemicals you're working with. This outlines the basic steps that an untrained person can use before professional medical assistance is available. Always know the nearest location of running water, because it's usually your first line of defense against chemical injuries. For small splashes, immerse the affected area in running water for at least 15 minutes. For larger exposures, get to a safety shower as quickly as possible. Remove contaminated clothing and stay in the shower stream for at least 15 minutes. You may want to keep an extra set of clothing with you in case you have to change. As we've discussed, many water treatment chemicals are highly corrosive, and getting them in your eyes can cause severe damage. So if you're splashed, you need to go to an eye wash station immediately. Keep your eyes open and flush them for at least 15 minutes. Inhaling hazardous materials can be dangerous, even deadly. If someone is overcome by fumes, get them out of the area and into some fresh air. Consult the container label or MSDS to see if they may need immediate medical attention. Swallowing a hazardous substance is extremely dangerous. If this occurs, consult the MSDS immediately. It may be necessary to dilute the chemical with water or milk, or induce vomiting. However, in some cases, vomiting may cause more damage. Seek medical attention after any exposure to a hazardous material, no matter how minor it may seem. Some chemicals have delayed or long-term effects, so be sure to supply medical personnel with a copy of the MSDS. Your employer counts on you to do your job safely. So you need to know as much as possible about how to work with potentially hazardous chemicals safely. If you learn about the chemicals that you work with, pay attention to container labels and material safety data sheets, wear appropriate personal protective equipment, and stay focused on what you're doing, you'll go home safe and healthy at the end of the day, every day.